Welcome. This video is going to take a look at Section 1 of Chapter 3 in the Brown SL Chemistry book. And Chapter 3 starts looking at periodicity, which means you have to look at the periodic table, because the periodic table is said to be a map of chemistry which studies trends or patterns of elements. But it gets the name periodic because there's these repeating or periodic trends that are incorporated in it. And Mendeleev's insight to leave blanks for undiscovered elements was really just incredibly insightful and brilliant, and also really accurate, just spot on as far as elements he knew we would someday discover. So we now know that periodicity is a direct consequence of electron configurations, that's really what gives these chemicals their similar chemical behavior. Okay, some terminology and symbols you should keep in mind with the periodic table. First of all, the elements are arranged in order of increasing atomic number, which is abbreviated Z. And remember, that's really increasing number of protons. Groups or families are the columns, and they're arranged in families according to how many valence electrons these elements have. The rows, or the horizontal rows, the periods, correspond to the energy level being filled. So there's a total of 7. The odd shape is due to the blocks, the S, P, D, and F block, which places elements not only in a family according to how many valence electrons it has, but where are those valence electrons going? Which orbital is being filled up, the last orbital being filled for that particular element. And then you should also notice that IB numbers using groups 1 through 18 instead of A and B groups. That's much more common internationally than the American system of A's and B's. So group 1 and 2, 1A and 2A are still the alkali and rare earth metals, but then the transition metals go from 2 through 12, and then you start again with 13 being what we think of as 3A, 4A, etc. So 13, 14, 15. So you just kind of drop the 1 in front and you've got the A system back. But this 1 through 18 is the International Convention, and it's determined by the IUPAC, and you'll see those initials show up in our book. It's the International Union of Pure and Applied Chemistry. So metals versus nonmetals. This is the big distinction on the table. The left side are the metals, and it's more than just half, but the left side is metals. The right side is nonmetals. And then there's this zigzag line where you have metalloids, where you have elements that tend to have some properties of each. So properties of metals: solids at room temperature, all except mercury; shiny, many are silver or gray in color, in fact virtually all of them except for gold and copper. They're malleable and ductile, so you can flatten them out or stretch them into wires. They're very very flexible, I guess would be a way to think of it. And they're good conductors of heat and electricity, which we now know is because of these delocalized or easy to move electrons. Nonmetals, though, tend to be gases at room temperature. Some are liquids and solids, but many are gases. They're clear and colorless. They're poor conductors, and if they're solids, they tend to be brittle. Metalloids, then, have some characteristics of both metals and nonmetals, but it's not the same characteristics for each metalloid. For example, aluminum technically is a metalloid, but it's very much like a metal. It's got very many of metals characteristics and virtually no nonmetal characteristics to it. Silicon and graphite both look much more like a nonmetal, but both are fairly good conductors, or what we call semiconductors. So metalloids tend to physically be more like the metals, like aluminum looks like a metal, but chemically they tend to behave more like nonmetals, and that's just kind of a general rule of thumb. Families you should know. These are family names you should recognize. The halogens are group 17 with 7 valence electrons, so they're the most reactive nonmetals. Noble gases are group 18 with 8 valence electrons, just 2 for helium. So this is a very stable, inert group of gases. They're also called the inert gases. Alkali metals are group 1 with 1 valence electrons, making them really reactive, in fact, the most reactive metals. And they tend to form basic solutions, which are called alkali solutions, which is where they get their name alkali metal. The transition metals are all the D block, and technically the F block too. But we tend to call them transition and intertransition metals, with transition metals meaning the D block elements, which have multiple oxidation states except for silver. And then the intertransition are those 2 rows at the bottom, and each row has a name, the lanthanoids and the actinoids, and they make up the F block. And most of those elements down there are either really rare or they're man-made, which are also called synthetic or transuranic elements. So that's a little introduction to your periodic table.